Hey everybody.
Hi.
Way to interrupt.
Sorry.
So this is the assignment 26 notes. This is hypothesis testing with two samples. All right. So before we get into actually doing some hypothesis testing, there's a few more things you need to know. They're going to be a little bit different this time versus one sample. The first thing you need to know about is independent and dependent samples. So two samples are independent when the sample selected from one population is not related to the sample selected from the second population. So, for example, the scores of my students on test 5 versus the scores of Rachel's students on test 5. All right, those two samples are not actually related to each other because if my students happen to all make zeros, that doesn't mean that it's going to affect Rachel's students. By the way, guys, don't make zeros. But it wouldn't affect Rachel's
Way to
students
go, my class. Woo.
because they're going to get zeros anyway. Sorry, Rachel's students.
Did you say my students are going to get a 0? My students would never get a 0. They are perfect.
Whatever you have to say.
Back to the problem.
But so either way, those two scores aren't related to each other. All right. Something can happen to one of the scores and it doesn't affect the other, so they're independent. Now, two samples are dependent when each member of a sample corresponds to a member of the other sample. So for example, if sample 1 is 30 times of people who run an obstacle course with no training, and sample 2 is 30 times of the same people running the same obstacle course after a week of practice. This time, these two samples are related because it's the same exact people, just after a week they got some extra practice. They'll probably do a little bit better, but the two samples are related to each other. All right, so those are called dependent samples. Now, for this class, we're only going to be worried about independent samples. So you're not going to get any that are dependent. They're done a bit differently. But whenever we're doing the PHANTOMS acronym, whenever we get to the assumptions, you do need to actually put independent as one of your new assumptions. All right, and then next up is degrees of freedom.
All right. So let's look at degrees of freedom with two samples. So degrees of freedom for the test with two samples will be based on if the population variances of the samples are equal. So you will see that in the problem. So there's no calculation on that part, where it will say the population variances are equal or the population variances are not equal. So if N1, that's your number of samples in the first population, and N2 is the number of samples in your second population. So let's look at the two different ones. If the variances are equal, your degrees of freedom, what you're going to do is add up your two sample sizes and subtract it by 2. So sample size 1, sample size 2, minus 2. If the variances are not equal, then the degrees of freedom, you'll take the smaller, whichever one has a smaller amount out of the two sample sizes, and subtract it from 1. Well, subtract 1. So let's look at hypothesis testing with two samples. This will be done very similarly to hypothesis testing with one sample, which we've already done. The main difference is how we calculate our test statistic, or a standardized test statistic. So Z or T. We're going to use the Excel sheet and it will calculate these values for you, but you still need to know which is which and what to do with it after. So we're only going to look at Z or T, not anything else like proportions or any other test. All right. Example 1. Oops, I'm giving you away all my answers. All right. So a group claims that there is a difference in the mean starting salary between Texas and Louisiana. The results of a random survey of 250 people in each state are shown below. The two samples are independent. Do the results support the group's claim if alpha is equal to 0.05? So here's the information for Texas: the sample mean, population standard deviation, sample size. Then here's Louisiana. Here's the sample mean, population standard deviation, sample size. Speaking of Louisiana, do you say Louisiana or Louisiana? Because I kind of switch between the both of them.
I usually say Louisiana.
Is that the proper way to say it? Because I used to say Louisiana, or I switch kind of.
No clue. It's the way I've always said it.
All right. Well, I was just curious. Okay, so let's talk about the parameters. So you want to label basically what mu is, like your two means. So the first mean is the population mean starting salary month. Oh man, there was just extra words in there. Sorry about that. The population mean starting monthly salary in Texas. Goodness, that was a mouthful. Population mean 2, this is the same thing but for Louisiana or Louisiana, whichever way you say it. The population mean starting salary. Oof. What happens?
Starting monthly salary. That's how you say that.
Starting monthly salary in Louisiana, whichever way you say it. All right, now that's parameter. We're done with that. Now our hypothesis. So a group claims that there is a difference. So difference means not equals, just like same means equal, difference means not equal. So our claim is in our alternative hypothesis right here. So the opposite of not equals is equal. All right, now for our assumptions. So it needs to be random. So we have a random survey. Both of your sample sizes are greater than or equal to 30. Both samples are independent, so they don't have anything in common. And population standard deviation is known. All right, so with those assumptions, we have a 2-sample z-test. So before you had 1 sample and now you have 2 samples. And because we're not equals, it is 2-tailed. All right, now to the fun stuff. Go ahead. I need to stop sharing. Hold on.
Yep, you stop sharing yours. Now I'm going to share mine. Okay, so there's some bad news and some good news. The bad news is to find Z and T for these, it's not as pretty as it was before. You can't just use the standardize function in Excel anymore. It's a little bit more complicated now because now there's 2 different sample means, 2 different standard deviations, 2 different sample sizes. So that's the bad news. The good news is you don't have to worry about that. Because if you notice, Excel doesn't even let me change this cell right here. And that's because I'm going to give all of you this Excel sheet so that you can just type in the values that you have. It'll tell you what Z or T is depending on the situation. You do have to know which one to plug it into. So we have to know that we're trying to get Z. All right, and you do have to know what to do with Z after that. But this takes care of the rest. So if we go ahead and just fill in our values, it's 3060 and 1 is 250. Sigma 1 is 960. And by the way, be careful because in the notes, it does list them as the sample mean, then standard deviation, then the sample size. In this, the sample size and standard deviation are backwards. So just make sure you're paying attention when you plug it in, that you don't plug stuff into the wrong spot. Then same thing for the second sample. So 2,910, 250, and 845. And it just tells you your Z right away. So we get Z is equal to 1.85 approximately if we round it to 2. All right. So that's the new part. Once we get our Z though, to find our p-value, it's going to be the exact same thing. So this was a two-tailed test, and we have the Z that's on the right. So if I just draw a quick picture of this. Oh, Excel's not gonna let me draw right now. Okay, I don't know why Excel's not letting me draw right now, but essentially this is the one with just the tails on each side. Our Z is positive, so that means we have the right tail that we want to find first. So here's what we do. If we did equals norm.dist of this, comma 0, comma 1, comma true, the 0, 1, and true, same as always, then that's giving us the area to the left of this Z value. That's not what we want. We want the area to the right of it. We want to grab that right tail. All right, so we do 1 minus that. Now that's the area of the right tail, but that's just one of the tails. Remember, this is a two-tailed test, which means we take this and we multiply it by 2. So you could just do 2 times all of that. And we get that our p-value is 0.0637 if we round it to 4 decimal places. And I'm gonna stop sharing and let Rachel go back to the notes.
All right. So we have Z is equal to 1.5 and the p-value is 0.0637. So again, our question becomes, is our p-value 0.0637 less than our alpha of 0.05? So if you just want to put in 2 decimal places, like you're having a hard time figuring it out, then let's look at it. Is 6 cents less than 5 cents? No. So we fail to reject the null hypothesis. It is not less than 0.05. So now comes our conclusion. There is not enough evidence at the 5% level of significance to support the claim that there is no difference in the mean starting salaries in Texas and Louisiana. And it pretty much goes with the same setup as the first set of notes that we did on this, the one sample. Same thing for hypothesis testing. Now let's look for example number 2. Well, didn't see any answers. I'm just gonna inch up. Okay, an appliances company salesman tells you that their appliances have a lower repair cost over its lifetime than their competitor. I mean, how many times have you heard this statement? Below are the results of a random sample of appliances from both companies and their repair cost. assume both populations are normally distributed at alpha equal to 0.01. Is there enough evidence to support the claim? So here's the information for the company, and here's the information for the competitor. All right, so let's look at the parameters. The first mean is the population mean repair cost from the company, and the second one represents the population mean repair cost from the competitor. So next comes H. How do you know what H is? Well, it's in the claim. It tells you that their appliances have a lower repair cost over its lifetime than their competitor. Well, lower, another way to say it is less than their competitor. So mean one, the company, has a lower repair cost over its competitor, which is mean two. And there's our claim. The opposite of it is greater than or equal to. All right. Now looking for our assumptions. And we can see that both companies have random samples. Both are normally distributed. The population standard deviation is known for both, but how do we know that it's independent? Well, we're talking about a company and its competitor. They're not going to have any kind of the same samples because they're competing against each other. Just like the two different classes. I mean, David and I are not competing. I mean, not really competing. But obviously my class is winning anyway. But same thing here.
It's okay. Just let her have her fantasies.
It's not a fantasy. It's real life. Nonetheless, company versus competitor. They're not going to have anything in common because they're competing against each other. So we can say that they're independent. So that brings us to a two-sample z-test again. And it is left-tailed because of the less than sign. All right, take it away with Excel.
Okay, so first thing we need to do is we just need to clear this out from our last problem, including the p-value part. Because remember, since this one's left-tailed, we're going to be calculating that differently. So you can go ahead and just clear that out as well. So if we go and fill in our data, our mean from sample 1 was 245. Sample size was 25. And our population standard deviation was 20. For sample 2, we had a mean of 251, a sample size of 20, and population standard deviation of 25. So it gives us that our z value is about negative 0.87. All right, so that is our z value. And now we have to figure out our p-value. Well, since this one's a left-tailed test, that makes our job much easier. Because if it's a left-tailed test, then all we need to do is norm.dist of our z, then mean of 0, standard deviation of 1, cumulative is true, and there we go. That's it. We don't have to do 1 minus or anything like that because it's left-tailed. So our p-value is 0.1914. And back to Rachel.
It's funny that you just say back to me every time. All right. So our t-test is z is equal to negative 0.87, and the p-value is 0.1914. So again, our question becomes, is our p-value less than our alpha? So is 0.1914 less than alpha of 0.01? And again, if you don't like p-value being so long, you can cut it down and compare that way. So is 0.19 less than 0.01? Nope, it is not. So we fail to reject the null hypothesis. It doesn't necessarily mean that the null hypothesis is true. It doesn't necessarily mean that it's false. It just means that we just didn't find enough evidence, which we say in the conclusion. There is not enough evidence at the 1% level of significance to support the claim that the company has a lower repair cost over its lifetime than its competitor. So if you ever do a hypothesis testing and you have something like this, there is not enough evidence, don't get discouraged. You can go back to the drawing board and collect more samples. All right, let's get to number 3. Ice cream. An ice cream stand goes to 2 different spots, rotating each day. Ice cream sounds really good right now. I could go for some cookies and cream ice cream. All right. Average profit per day over a random sample of days is shown below. Can you conclude there is a difference between the mean profit per day at the 2 different locations? Use alpha equal to 0.10. Assume the populations are normally distributed and the variances are not equal. So let's look at the first parameter for mean 1. The population mean average profit per day at location 1. And then for mean 2 is the same thing, but for location 2. All right, hypothesis. So we need to look at their claim and what they're saying. Can you conclude that there is a difference between the mean profit per day at the 2 different locations? Well, we talked about this earlier. Difference means not equal. So that is our claim in our alternative hypothesis, not equal. And the opposite of that is equal. All right, now to our assumptions. We know that they're random sample. We know that the populations are normally distributed. And again, location 1 and location 2, they're independent because it says 2 different spots. So they're independent. Here it's giving you the sample standard deviation. So the population standard deviation is unknown. So the S, that stands for sample. We don't know the population standard deviation. And the population variances are not equal. All right, so what test are we going to use? The 2-sample t-test. And it is 2-tailed. And just to reiterate, the population variances are not equal. So now we're going to get to Excel.
All right, so going back into Excel, whenever we're doing t-test, we actually have 2 versions of it. The first one is for when variances are not equal, which is why we state it twice in the both A and N parts of Phantom. And then the second one is when variances are equal. All right, so for variances not equal, we're going to go ahead and just put everything in here. So we got 0.48, 30, 0.05. Oh, wait, no, sorry. I'm plugging in the stuff from problem 4. Ignore that. 473, 8, 39.7, then 459, 18, and 24.5. All right. And then, did I make a typo again? 39.7. There we go. Now it's correct. So this is a perfect time to say, be careful what you're typing in, because obviously, even if I'm not paying attention, I'm typing in wrong stuff. And if I hadn't caught that, that would be awkward for the notes. All right, so once you plug that in, again, the formula is already in here. It automatically calculates t for you without you having to do anything. All right, so we're ready to get our p-value. Now remember, for t, it's nice and easy because Excel has the built-in functions that already work for left-tailed, right-tailed, or two-tailed tests. In this case, we want a two-tailed test. So it's going to be equals t.dist dot 2t, which stands for two tails. And for this, we need two different things. The first is the t that we just found. The second is the degrees of freedom. Now, remember, this is variances, not equal. So the degrees of freedom is just going to be the lower of the two sample sizes minus 1. So our two sample sizes are 8 and 18. 8 is the smaller one, so you just do 8 minus 1 is 7. So 7 is our degrees of freedom, and we end up with 0.3870 as our p-value. I'm not going to say it back to Rachel this time.
But I think you just saying that part kind of.
Nope, doesn't count. Half the students are skipping over this part in the video anyway, so.
Do you think so? I hope not.
Skip the video. Good job if you're still here.
All right, so T and O. T is 0.92 and O is 0.3870. So again, we have to ask the question, is our p-value less than alpha? So is 0.3870 less than our alpha? And again, if you are not comfortable with 4 decimal places and comparing it to 2, you can cut it down and just round. Is 0.39 less than 0.10? Nope. So we fail to reject the null hypothesis. All right. Are all of these failed to reject? That's so sad.
Oh no, the last one is not.
Interesting.
Spoiler alert.
I was just going to give the idea of kind of, what was the word? The I lost the word. Okay, whatever. Gosh, that's really going to bother me. There is not enough evidence at the 10% level of significance to support the claim that there is a difference between the mean profit per day at the two locations. Suspension, what's the word?
I have no idea what you're trying to say right now.
I don't know. It's not suspicion.
Okay.
It's like when you're anticipating suspense. Suspense.
Oh, you were literally just trying to say suspense?
Yes. I was trying to build up the suspense. That's what I was trying to figure out what the word was. I'm so sorry. I'm really, really tired.
She
And
always says that, but whether she's tired or not, she's just always like this. So
when I'm tired, I get more chatty. Sorry. I'll pull it in, pull it in. Okay. Number 4, a company claims that its processor takes less time for one clock cycle than its competitors. A study is done on a random sample of both processors to see how long each takes for one clock cycle, and the results are shown below. At alpha equal to 0.05, does this study support the company's claim? Assume the population variances are equal. There's a lot of S words in that one, and I'm just messing up on my words. Processor and study and support and okay. So for the parameter, the mean one is the population mean time for one clock cycle for the company's processor. For mean 2, again, your parameter is just stating what these two are. So when you set up your hypothesis, you know exactly what you're referring to. So the other one is the population mean time for one clock cycle for the competitor processor. So one's for the company, one's for the competitor. All right. So let's talk about the hypothesis. Its processor takes less time. So it is a less than, and that goes in our alternative hypothesis. That's where our claim is. And the opposite of less than is greater than or equal to. And now we can go into our assumptions. We know that we have a random sample for both processors. So they're both random. Both sample sizes are greater than or equal to 30. So that's good. We have a company versus competitor. So we have the independence again. Population variances are equal. So we have that. And then lastly, the population standard deviation is unknown because we're given our S instead of our sigma. So here we have our assumptions. So we will be using the 2-sample t-test. It is left-tailed because this is pointing to the left and the variances are equal. All right, so let's look at Excel for the last time, at least in this video.
all right. Share. Okay, so here is the one when variances are equal. All right, so you'll notice there's two different things up here. And especially this one does not necessarily look pretty. You don't have to worry about this one at all. The top one though actually calculates the degrees of freedom for you. So it just does the N1 plus N2 minus 2. That was on the first page of the notes. It will do that part for you. So know that that's the degrees of freedom. This last spot down here, that's going to be the t-value that we're going to get. But that middle spot is just a step in getting the t-value. But just appreciate this nice long formula and appreciate the fact that y'all don't have to do it because I already did it for y'all. And appreciate the fact that we're using Excel and y'all don't have to do that by hand. All right. So we're going to go ahead and plug in all of our stuff. So we got 0.48, 30, 0.05, 0.51, 32, and 0.07. And this just automatically gives us our t value. Now, again, this is still just the t value, so we still got to find the p value. So this was a left-tailed test. So you get to do equals t dot dist, because if you don't put dot 2t or dot rt, just t dot dist by itself is automatically left-tailed. And if you forget that, it even tells you right there, returns the left-tailed. All right, so that's the one we, excuse me, that's the one we want. Our t is that. Our degrees of freedom, again, it's already calculated, so it's right there for you, and cumulative is true. And we get that our p-value is 0.0292. All right,
Back to me.
one last time, back to Rachel. The notes are almost done.
I know, we're almost at the end. How exciting. You know what's so sad? This is our last set of notes.
It is.
That's so
I figured we could take the very end of the video to talk about it real quick.
Okay. So the t, the test statistic is negative 1.93, and the p-value is 0.0292. So since David told you earlier that this one is rejecting, let's figure out why. So 0.0292, is that less than 0.05? And yes, it is. So we are going to reject the null hypothesis. So now to our conclusion. There is enough evidence at the 5% level of significance to support the claim that the company's processor takes less time for one clock cycle than its competitors. So that's it. Man, can't believe that's our last set of notes.
So I did just want to say thank you all for sticking in there with all these notes. I know 26 different sets of notes and 26 different homeworks was a lot at some points. And I know there's been a lot of different terms and things like that, but good job for hanging in there.
Yes, great job. And make sure that you finish strong. Don't give up now. Don't slack off or anything. You can do it, and we're definitely behind you. And yes, David students, I was just joking earlier. I know y'all aren't going to make zeros.
Rachel students, I was not joking. No, okay.
My students are always perfect, and so they're going to make perfect scores. So, you know. Anyway.
Whatever you say.
Just great job. Finish strong, and you can do this. That sounded really fake, but I really didn't mean it fake.
She's always pretty fake, so I mean, it's just how she is. Right. But don't forget though, there is still test 5 and a final left. So please don't just brush all this aside now that you're done with the notes. Make sure you go back over these videos. Start now if possible, making sure that you remember the things back from like notes 1, because it's been a little while. So
just a little bit.
Because the final is going to come up sooner than you think. Like it's going to come up on us really fast after we get back from Thanksgiving.
And now we know what semester we made the video.
Yeah, if y'all are in the spring semester, never mind about Thanksgiving. That's so far away from now. I mean, you realize on YouTube, it has the date that you published the video, right?
I know, but still, who looks at that?
Well, everybody probably already clicked off the video now anyways. So
So now
actually,
would be a good time to give answers from the test.
or how about this? If you're still watching and you're still putting up with our dumb little conversation right now, then at the very, very top of your notes, put a smiley face in one of the corners, just so we know that you were still here.
Is there an incentive as to what they should receive? They put a smiley face.
They get a smiley face from me back.
What? I guess. Anyway, all right. So I think that's a good place to stop. Great job, y'all. You've made it to the end. Don't quit now.
We'll see y'all in the final exam review videos.
Eek. So excited. Not really. No, David, you're not supposed to say it. Or
My class. I thought you said your class was looking forward to it.
he's just giving away all of our secrets.
You literally told me you already told your class.
Yeah, I'm sure they forgot. It's okay.
Well, they'll forget again.
Oh, you're
All
gonna
right.
this,
On
right?
that note, bye everyone.
Bye.